Okay, good morning. Let me know in the chat if you can hear me so I can start with today's class. You can just type yes so we can start with today's activity. All right, thank you, Perez. Yeah, Moses, thank you. I think we can start. Let me just pull this up. Um, all right. First of all, I want to thank you once again for coming for this morning's lecture. I told the class rep, this is an arranged class. We usually is supposed to be 8 to 10, sorry, 9 to 10, but because I want us to finish most of our lectures early, I requested we start at 8, then we end probably around 10 or some minutes to 10, so you can go for your other lectures. In today's activity, we're going to talk about computer networks. Please, I will advise all of you to try your best to go through the PowerPoint slides that I will put on the VLE together with the lecture material that is already on the VLE. And the reason is most of the things I will say here are in the lecture material. I would want you to go through it. If you have any question, you can put it in the forum on the VLE page. I'll come in and answer some of the questions that you have. And if any of your colleagues also know the answers to some of the questions, they can also answer. As I told you from the beginning of the lecture or the class, I said people who do answer questions that are put on the VLE, I have a mark for them. So I advise you try your best to also get some of those marks that I give on in the VLE for the forum aspect. All right. Now let's start with today's activity, which is computer networks. Okay, so at the end of this lecture, these are the expected. These are the objectives and the expected outputs that we hope all students will get to, have an idea of. Now, the objective for this particular lecture for computer networks, the first is to help students understand the basic networking technologies. Just like in any field, in your mining field, there are certain technologies that you'll be using in your field. And of course, in computing too, or information technology, there are certain technologies that you need to be abreast with to be able to know some of the technicalities whenever we speak in area of computer networks. So we will talk about some of these terminologies. And at the end of this lecture, you should also know what data communication is. I'm going to talk about them. You would also have an idea of the various components of data communication and the type of communication media that exists whenever we talk of computer networks. And finally, you will have an idea what computer network topology is. I will hit on each one of them, so don't really worry. You will get to know virtually everything that needs to be known. So let me activate the pen, so I can highlight some of the things or point some of the things for you to see. All right, so these are the 5 main objectives for this particular lecture. I hope to finish this lecture today. If not, then possibly we'll continue next week. Now, anytime we talk about computer networks, just in our normal, socialization, sometimes we say this guy has networks, or this guy's daddy has lots of networks, maybe in the political environment or stuff. Sometimes you also say whom you know, you know. So networking has got to do in a social life has got to do with knowing people in one way or the other, and possibly because you know them, they are able to maybe render certain services for you. So in computing or in computer, we also have what we call computer networks, and it's also about just about the same um, mode of operation. So networking in computing is an electronic linking of geographical dispersed device required to accomplish telecommunication. So first of all, when you hear of computer networks, um, from previous lecture, we said anytime we try to define what a computer is, we always will have to incorporate the keyword electronic device, something that needs to be electronic. So in the same way, if we are talking about computer networks, then we also have to say, we have to bring in this same keyword, which is electronic. So networking is the electronic linkage or the linking of geographically dispersed devices. So by saying geographically dispersed devices, let's take this for example. Facebook, they have their mainframe computers located somewhere in US, but you also have your phone or your laptop. You browse to Facebook. How is that possible? Well, the mainframe server or mainframe computer is located somewhere in US, which is not in the same geography as um, you situated here in Takwa, Ghana. So to be able to have access to the information that is in US, we need something we call computer network. So that is where computer networking comes in. So it's an electronic linking of geographically dispersed device, Facebook's main server, which is one of the devices, your laptop or phone, which is also another device. And these are geographically dispersed, and we are able to communicate with each other with the help of um, networking. And the whole idea is to be able to communicate with these devices. So the reason for networking generally is to be able to um, share resources, network resources. So anytime you are asked, okay, what is computer networks? This is the definition that is given that tries to explain it into detail. So computer networks is a collection of computers. The computer can be your phone, anything that is electronic. So it's a collection of computers and other hardware connected together to share data, hardware, software, program, and facilitate electronic communication. Now let me break these words down. So first of all, is a collection of computers and other hardware. So a printer, for instance, is a hardware. It's an electronic device. Is a hardware. It is not a computer. But because of networking, we can have a printer situated in one office and about 500 computers connected to the same printer. So when a command is issued by one of the computer, that command takes the information to the printer, and the document is printed out. So in this case, when we say other hardware, a printer is also a hardware, but it's not a computer. So that is what we mean. So it's not only computers that get connected on a network, but other hardware too can also be connected onto a network. And the reason for the connection is to be able to share data. By sharing data, I mean to say, if you have one information maybe on your computer, you can send it to Akosia's computer via email. And this is being done because of computer networks. So we are able to share data from one point to the other. We are able to share hardware. And in this case, the sharing of hardware could be a printer. So one printer in an office can be used by 10 people. So it means 10 people are sharing the printer hardware. An institution or an organization, instead of having to buy printer for these 10 people will rather have just one printer and share it amongst these computers. And this is possible because of computer network. We are also able to share software. In this case, for instance, like an antivirus, we can have an antivirus located somewhere on a remote server, and we have about 10 computers connected to that particular server sharing the same antivirus. So the antivirus itself has been installed on the computer, one computer that is serving the other clients or the other computers. All right, just a minute. Pardon me, I have a little cold today. Yes, so let's get going again. All right, so we can also share programs. We can also facilitate electronic communication, that is, being able to talk to each other. So the whole idea of computer networking is to share network resources. And the network resources could be in the form of a hardware, a software, a program, or any other thing. So computer networks, the whole point is to be able to share resources. And the resources could be in any form. Now, the basic foundation for a computer network is data communication. I told you computers do not understand anything but zeros and one. So if you have a Word document and you want to send to somebody, it needs to be converted to the zeros and ones that is understood by the computer and sent across to the individual that you want to receive that information. So the basic foundation for computer networks is data communication. That is the process of exchanging data between two devices via some form of communicating media or communication media. Now, the person sending information to the other is termed as the sender. And the individual also receiving that information sent by the sender is what we normally term as the receiver. And the medium or the channel through which the information is sent by computer A or Akosia to AMA, that medium or that channel is what we call the medium. So the medium could be a wireless. So if I am connected to a wireless in the office, you probably will be connected to your cable at a computer lab or computer cafe or wherever. So I am able to send you information through the medium, which is the wireless medium, and you are receiving the information through the wide medium. So the channel through which the information is sent and the recipient also, the channel that the recipient also receives the information, that is the medium. So anytime you hear of computer networks, these three things should always be in your mind: the sender, the receiver, and the medium through which the information is sent to the receiver is what we call the medium. The channel is called, we call the medium. Now, there are basically five main keywords that you should have in mind in here. Now, the first one is message. So generally, the information that is being sent or communicated between these two individuals, that's the sender and the receiver, is what we call the message. And the message could be in any form. It could be an email. It could be maybe a video that is being sent across, like how we've been sending information through WhatsApp to our friends. It could be a text message. So the piece of information to be communicated is what we term as a message. In fact, these are very important. I know most times it comes in the exam. And I'm reiterating again. After this lecture, I also entreat you go through the lecture material that has been given to you. Of course, as you already know, God willing, next week from 8 to 8:30, we'll have another quiz. So just get yourself ready for that. Now, the device that sends the message, which is a piece of information to be sent to another person, is what we call that device that sends the message is a sender. So, for instance, I'm using my computer. If I'm sending information to you, my computer is the sender. And if you are receiving that information on your phone, your phone is the recipient. Your phone is the recipient. So in this case, I'm teaching via online. You could hear me through your phone. So I'm using my laptop. So my laptop becomes the device that is sending the information, which is my voice together with the PowerPoint slides that I'm projecting for you to see. So that is the sender. So my laptop is the sender. You are probably listening to me with your phone. So the recipient or the receiver is your phone. If you are using your laptop is also your phone. Now, the device that receives the information is the receiver. The medium, as I talked about in the previous slide, so that is the transmission medium, is the physical path by which a message travels from the sender to the receiver. So the route where the information is going to be sent through is the medium. It could be a wireless medium. It could be via a physical cable. So that is an example of what the medium is. Now there is something that is very important, which is the protocol. So anytime you hear of a protocol, you should bear in mind that protocol is a set of rules that represent an agreement between the communicating devices. So in that case, the sender and the receiver. So the protocol is a set of rules that represents the agreement between the sender and the recipient. So if you want to probably check facebook.com, the protocol that you'll be using is HTTP, which is the hypertext transfer protocol. So the receiver would have to use that protocol to be able to talk to the sender. So that is how come when you type facebook.com, automatically you will see HTTPS possibly : /facebook.com. So the protocol is the agreement between the sender and the receiver. So for instance, if you are coming to my office and you're probably assuming I'm not expecting you and I'm busy in my office, I get myself locked, and you keep knocking at the door because I don't know you want to come and see me, and I'm also busy doing something, I will choose not to mind you. So in that case, there hasn't been any sort of agreement between you and I that you will be coming to see me. So that sort of agreement between you coming to see me and me receiving you is what we call a protocol in layman term. So the set of rules that represent an agreement between these two communicating devices is what we call a protocol. Of course, sometimes we also say that this individual has a protocol. So if you have the protocol, there's a high probability of you going to, getting accepted maybe at a place that you need not accept to be accepted. An individual who has a protocol with maybe the vice chancellor or the president of Ghana, because he already has this agreement with the president of Ghana or maybe the vice chancellor of the university, he has a protocol. So that agreement between him and the vice chancellor is already there. So he can walk in to the office and have a communication with him. So that is how protocols work. So in the area of computer communication, when we talk of protocols, this is what we mean. Get yourself reminded that it's a set of rules that represents the agreement between the communicating devices. Now, from the previous definition given here, which is expanded in here, a message is a piece of information to be transmitted from the sender to the destination. And the example of the messages are files, email messages, and web pages. If you go to a university website, you are being served some of these pages. Messages are identified through message headers. Yes, so in your email, if you want to see certain details about the email, if you check the headers of the email, you'll see all those details. That will give you maybe the channel, the protocol that is being used to get the communication and all of that. We'll talk about emails in a later, I think it's in one of the slides, we will get there. All right, so now you have an idea what a message is. So it can be transmitted in the form of a document, a picture, a video, an audio. And these things are things that we have been doing with our mobile phones. Now, in computer systems, just a minute. Just bear with me a minute. Um, excuse me. Okay, I think, yeah, I think it's back. Okay, so I think I can continue. Sorry about this. Yes, so yes, so a message can be transmitted in the form of documents, pictures, videos, or audios. If you don't know what an audio is sound. Video is, people moving and just like the videos that you're watching. Pictures, the same way, the pictures that you take with your phones, those are pictures. Documents could be a Word document, a PDF. In some cases, we can also say, of course, a picture is also a document. It depends on how you want to relate to it. Now, in a computer system, this message is represented and stored in the form of binary data. From what I said previously, I said the computer does not understand anything but zeros and ones. If that is the only thing that it understands, then it means to be able to communicate with it, all information needs to be able to convert it into zeros and ones. So your pictures, your documents, and your audios would all have to be converted to zeros and ones for the transmission to occur. And when the transmission gets to the recipient, he is able to see it in the form that you sent it. And that is what is readable to us. Now, the binary data cannot be transmitted directly through a medium. Rather, they need to be converted into signals. So, for example, submitting data through a coaxial cable, we'll talk about what a coaxial cable is. We need to convert the data into electrical signals. If you don't know what a coaxial cable is, a coaxial cable is a cable that is being used to connect from the satellite dish, like your multi-TV. The cable that comes from the satellite dish to your multi-TV, that is a coaxial cable. So you have an idea what a coaxial cable is. All right. So now looking at this, these are data exchange examples that are being listed here. And on the right, the middle is what we have the sender and we have the receiver. The sender and the receiver. So most times I try to find out from students what they think. All right. Before I continue, Moses asked a question. How are many computers connected to a printer? Yes, usually that is Moses Dakwa. Usually, now there are certain printers that we call network printers. When we say it's a network printer, what we mean is where you have the network port, where you connect your network cable, which I remember I showed you one the last time. I can find one. Yes. So this is the network cable. I don't know if you can see it. Let me go this way. Yeah, so this is the network cable. Moses, this is to you. This is the network cable. So where you connect this on your computer, this side, and this to also maybe to get internet access. The printer has a port where you can print, you can connect this to. So most of these printers, we call them network printers. And usually such printers have an N to their name, an N. So the N tells you it's a network printer. Let me see if I can show you an example online right now. Um, okay, so let me use this as an example. So I was saying you can connect so many computers to maybe one printer, and this is printer one, this is printer two. Let me see if I can open it in a new tab and increase it for you to see. Okay, so we have the printer here. This is connected wirelessly. In fact, all these computers are connected wirelessly to this device. And this is a printer. So there are two ways of getting connected with the printer. Now, the first one is you can, if the printer is not a network printer, it means by default, it doesn't have the ports where you can put this cable in there. Where you can put this cable. It doesn't have the port where you can put this cable in there. The printer does not have that port. So for such printers, what you can do is for set printers, what you can do is you can connect the printer cable, the normal printer cable, to one computer. And once that computer is connected to it, this computer is connected to a network, which is connected wirelessly to a network. So you can share, we have something we call sharing of the printer. So you can share the printer that is connected to this one. This computer is connected to this printer using the normal printer cable. Once it's connected, then you can share the printer in this computer on the network. Once you share it, then it means these devices can now see the shared printer on the network and now prints through this printer. So that is one way for printers that do not have the network ports. Now, in the other way, the printer, those printers that usually they are modern printers, those printers that have the network cards automatically can connect directly to the wireless or the connect directly with the cable to the network. So you don't need any computer to be connected to it. So this one will probably be standing alone somewhere here, and all these computers will be connected to it. Once all these are on the same network, then it means we can print on the printer. So that is the essence of networking. That is the main reason why we do networking, to be able to share network resources. All right, so in this case, we are sharing the printer hardware itself. Okay, so I think we can go on. Let me see if there is. So in sharing, it's usually, you see, this is the printer. There's a printer that is available. So on that computer, you can share this particular printer, and any other person on the network will see this printer and print through it. So that is the importance of having a network. Now, so first of all, let me see. Moses still asked about 500 computers being connected via Wi-Fi or wireless. It could be Wi-Fi, it could be wireless, but of course, it depends on how the configuration is and how fast it is. If the network is good and is able to handle 500 computers at a go, then you can have that one connected via Wi-Fi. Of course, you should be aware that using the cable is faster than using the wireless. So it's always advisable you use the wired, the normal cable, like these cables. The wireless will also work, but it also has its limited speed. Yeah. All right, so you can have more than 10 computers also working. All right. So the purpose of the data exchange for this is printing a file. For printing a file, the sender always would have to be the computer. Of course, if I want to print my Word document, it's my computer that is going to send the command to the printer. So my computer becomes the sender and my printer becomes the receiver of that information that is going to be printed. So the receiver is the printer using this data exchange example. Secondly, now we have the second one, which is the transmission of an email message. Now we are saying computer, which is the mail server, and we are also saying computer, which is the mail server. It looks a little, you will wonder, why is the sender a mail server and the receiver also a mail server? And there is a reason for that. And the reason is, now if you are sending information to, assuming I'm using Google Gmail, and I want to send an email to Amma, who is using Yahoo. Now, Gmail have their own server, mail server. Yahoo also has their own mail server. They are not the same. At the point where I am using my computer to send the email, I'm rather having access to Gmail mail server. So in that case, Gmail mail server will serve as the sender. Now I want to send an email. I'll open my email. I'll go to my inbox. I'll open my email. I'll go to compose. The interaction I'm having is on the mail server, which is Gmail. So in that case, the sender is Gmail. And the receiver, the information that is being sent, Gmail server, the mail server itself, what is only doing for me is to give me access to my mail. And by having access to my mail, we have something we call clients. So I'm using the clients application, which could be my browser, to have access to the Gmail. The mails itself reside on the Gmail server. So if I'm creating an email, I'm using um, my client's application to connect to the Gmail server itself. So whatever I do in my client environment, be it composing an email and sending to somebody, that composition is done on the mail server. So in that case, it is the mail server that I'm talking to. And that mail server is the one that is going to send the mail on my behalf. So in that case, the sender will be the mail server, which is the Gmail server. Now, when the information is being sent through the Gmail server, it is received not by Akosia or Ama directly, but it is the Yahoo server that receives the information that I have sent. So that information is received by the Yahoo mail server. So the Yahoo mail server is the recipient of the message that was sent by the Gmail server. I'm believing this is clear. Samuel Danso says, sir, with the network cable, it has only one head and one tail. So how can you connect it to maybe 3 computers or more at the same time to a printer? Yes. Okay. Samuel, I'll answer this question again when we move on to the subsequent slides. I'm believing you understand this one. So the transmission of an email message. I am the one sending the email. I'm using a mail client to send the mail. The mail client is an application given to me for me to be able to interact with the mail server. The mail itself, the mail that I will send is residing on the mail server itself. So the mail server is the one that sends the information to another mail server, which is Yahoo. So the sender is the mail server, the recipient is the mail server, which is the Yahoo mail server. All right. All right. So, of course, file transfer protocol also. Yes. So, Grace, you are right. When you say HTTP, of course, when you are interacting with them, when you are using the client, which is the browser, to be able to talk to the mail server, you are communicating through the protocol called HTTP. That is the Hypertext Transfer Protocol, which works on port 80. Now, the secured one works on port 80 and 433, 443. So that is a little secured than the HTTP. So, of course, HTTP is a protocol, which is a set of rules or arrangement that you have with the sender and between the sender and also the receiver. All right, so if you see says, if I connect a printer to a wireless network, can I enable printing operations to the computer from anywhere? Yes, it is possible. So, for instance, the way you are able to talk to, okay, now in my office, let's use an example like the VLE, which is the learning platform that you use to write your quizzes and the rest. It has something we call a public IP. And an IP is a way that uniquely identifies you on a network. We'll talk about that. I'll hit on that again. So wherever I am in the world, I can log on to the VLE server and do certain things on the VLE server. I don't have to be in Ghana because the IP that is on that particular server is accessible worldwide. But for other computers or servers that are like your normal computer, if you're connected onto on the network, it is only located on campus. So once you move out of campus network, I will not be able to have access to it. I'll explain further as we move along. All right, so transmission of the web page. We have computer, which is the web server, and we have the web client. So as I was explaining, the web client is the application that helps you communicate with the web server. And usually the web clients are the browsers, your Chrome, your Edge, your Mozilla Firefox, your Tor browser. In fact, any browser that you know of, those are clients. Those are ways to communicate to the web server. So if you want information, it's the web server that would send that information to you. If you go to google.com, you type google.com using your web browser. Let me use this as an example. Now I come here, I go to google.com. You see, I just typed google.com. Now when I click on it, google.com opens for me. And when it does open, you can see I have HTTPS. So the protocol that I'm talking to google.com is HTTPS protocol. So there is some sort of agreement between my browser and the server. So now, if I want to go to UMAT's website, I'll just type umat.edu.gh. So now this is all that I've done. So how do I now see umat.edu.gh website? It is the web server that is going to communicate that information to me. So the sender is the web server. It's the one that is going to send me the information that I'm looking for. And the receiver is going to be my browser, which is my Google Chrome. So now when I press enter, my browser, which is Google Chrome, is the one that is now going to see the umas.edu.gh website. So it's receiving that information from the browser, from the server. It is my browser that is now seeing that information. So as you can see, I think it's taking a little while. So my browser now becomes the recipient. Just like when I typed google.com, my browser also became the recipient. All right, so the information has now been served to me through the browser. So it's the browser that is giving me this information. And that information was sent by the web server. So the recipient is the browser, which is the client, and the sender is the web server. So that is what we mean by this. All right. All right, so Isa Haku, yes, you're wondering why the network cable is faster than the wireless. Yes, there are reasons for that. I will talk about it. Now, the network cable generally, because you are physically connected to the network, it is faster. Now, wireless has issues because, that is how come sometimes when you are browsing, when you try to when you are watching maybe Big Brother or you are watching something and the network and it rains, you see how the picture quality changes. The network becomes scrambled. You're unable to see the picture, and sometimes DSTV can go off, or even our normal. In fact, even our normal what do you call it? Stations will go off because the network is off. So wireless signals also have some sort of interference. We'll talk about it as we move along. If it rains, it also blocks or reduces the transmission of these signals. So that is a reason why sometimes we say the wireless, of course, the wireless is not the best way of communicating, but it also helps. It doesn't mean it's not so good. It is, but the cable is faster than that. We will talk about that. There are reasons for that. I will hit on them as we move along. All right, let's continue. The last one is data synchronization. Now, PDA is not necessarily being used compared to how it used to be used some years back. Yes. All right. So let me continue with this. There are more to go. Let's go to the next slide. All right. So Now, let's talk about this. We are talking about networks, computer networks, and the rest. So there is a reason for all of this. There is a reason why this is possible. Now we have something we call the OSI reference model. OSI stands for International Standard Organization, ISO. Sorry, Open System Interconnection. That is OSI, and it is being it is this the international standards that defines the OSI. So ISO, please be careful about this. International Standard Organization is responsible for the definition of the Open System Interconnection, which is the OSI model. So that is the reference model that is helping us to be able to do these connections, to be able to have computer networks, to be able to talk to or send information from one point to the other. Now, the OSI reference model is a set of rules and procedures that governs the data transmission from one layer to another, which we normally term as a protocol. So the protocol, as I told you, is a set of rules that is, or arrangement that is being organized between the sender and the recipient. Now, defining it very well in this way is a set of rules and procedures governing the data transmission from one layer to another. And we call this as a protocol. And this OSI reference model is being defined by this organization, International Standard Organization, ISO. So they defined this model. And they said this model is made up of 7 layers. There are 7 layers that comes in this model. So what are the layers? The layers are what has been outlined in here. We have layer 1 through to layer 7. And the layer 1 is what we see here is the physical layer. The data we have after the physical layer, we have the data link layer, which is layer 2. We have the network layer, we have the transport layer, the session layer, presentation layer, and application layer. And surprisingly, this comes in the exams almost every time. You should be able to know the order in which each of these layers is and the name of the layer itself. So for instance, if I say layer 3, you should know that is a network layer. If I say layer 7, you should know that is application layer. Now, how can you remember this? We have an acronym that we normally use, and that is, if you are a fan of pizza, then you shouldn't forget this acronym. If you are not a fan, you should also try not to forget. Put this at the back of your head. What acronym can we use to get this, to know this in order of the layers? Now, the acronym is please do so. The P stands for please do not throw sausage, pizza away. So if you're a fan of sausage, if you like pizza, never throw it away. So please do not throw sausage pizza away. So that is the acronym that we normally, I think the mnemonics that we normally use to remember where each of the layers fall. So please, that's the first P is always the physical layer. Do, data link layer. Not, network layer. Throw, transport layer. Sausage, session layer. Pizza, presentation layer. And finally, away, application layer. So please do not throw sausage pizza away. That should always be at the back of your head. Always try and remember this acronym. So when I say layer 5, so you can say please do not throw sausage. So session layer. That is layer 5. So we have the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Sorry. an application layer. Now let's talk about each one of them and how it works. So now let's talk about the first one, which is so when I say layer one, let's talk about layer one. Please, this order is very important. You should have this order all the time. The OSI reference model is responsible. It's a model that helps us to communicate with other devices that are connected on a network. So the first one is layer one, physical layer. That is the mnemonics that we're going to use. So layer one defines the protocol for submitting signals over a medium. So for instance, when you talk about physical layer, these are devices such as the Ethernet cable. Those of you who do not know the Ethernet cable, this is the Ethernet cable, the normal cable that we know. The coaxial cable, the cable that we use to connect from our satellite dish to our decoder, that is a coaxial cable. Fiber optic cable, you'll see that in subsequent slides. Modems. So those are what we normally term as the physical layer. So it's the first point of call when you want to have access to a network. So if you take up your computer and you are not connected to any network, the moment you take a cable to be able to connect to a network, you need the physical layer, which is usually your Ethernet cable, your coaxial cable, and the rest. Let's go to the next one, which is the data link layer. What does it do? It defines the protocol for transmitting data from one node to another in a computer network. Please try and know what each one of these layers is. It comes in the exams most of the time. Now, the data link layer usually is the basic hardware protocols. Sometimes the data link layer and the physical layer, they are more or less very closely related. So the physical layer defines a protocol for transmitting signal over a medium. And this medium usually is the cable, the coaxial cables, and the rest. The data link layer defines a protocol for submitting data from one node to another in a computer networks. And normally, of course, it could be a wireless signal, it could be an Ethernet cable, basic hardware protocols. Those are the ones that normally goes in there. Network layer defines the protocol for determining the correct routes or the correct path to ensure data transmitted by a sender will arrive at the correct destination. So usually when you talk about network layer, sometimes the network layer is also called the internet layer. And what it does is responsible for basic software protocol, which is the IP. So the IP is a way to uniquely identify you on the network. So the moment you connect your cable to a network, automatically the network is supposed to be able to identify you. So when you come to School of Petroleum and you connect to a wireless network or even anywhere on campus, the moment you connect your network card, your wireless network card, which is on your computer, which is part of the physical layer, to a wireless network, automatically the wireless network should be able to uniquely identify you, which is the computer that you are using, from the others. And how does it do that? It does that by assigning something we call an IP address, which is Internet Protocol. So the IP address is a way of uniquely identifying a device that has connected onto a computer. So anytime you are connected onto a network, anytime you are connected to a network, automatically you are assigned an IP address. So you should have that in mind. All right. If you are using your phone and you connect to the wireless on campus, automatically the wireless access point will give you an IP. and that is unique to you. So the IP is just the same as saying your phone number. Your phone number, you are the only one who uses that phone number in Ghana. In fact, in the world. So your phone number, which is numbers, is what uniquely identify you on the network in Ghana. If it is MTN, your phone number will uniquely identify you on MTN network. So that is the way MTN is able to know who you are, by your phone number. So in the network environment, we call it IP address. So switching and routing usually happens here. So by switching and routing, we mean to say once you have an IP address, you want to do certain things. So your movement, if you want to have access to Google, because you are uniquely identified on a local network on campus, now going to google.com, you'll be pushed to a different network for you to see google.com. So that is about the network layer. So IP addresses and internet layer, internet protocols usually happen at the network layer. You first of all need to have a physical card. If it is your phone that you are connecting to it, you first of all need to have a physical card, which is a wireless network card. All the phones that we are using now have what we call a wireless network card. And those wireless network cards are ways of connecting to the network. So if you don't have a wireless network card, there is no way you'll be able to connect to a wireless signal on campus. All right. Let's talk about the transport layer. It defines the protocol for making sure that the correct data arrives at the destination. So the moment you have been given an IP on the network, and you want to send an email to somebody or send a message to somebody on the network or whatever it is, the transport layer is responsible for making sure that the information that you are sending is going to Kofi and not Amma. If that information is meant for Kofi, it should go to Kofi. It shouldn't go to Amma. It is the transport layer that does that. It makes sure that the correct data will arrive at the right destination where it's supposed to go. So there is no way you send an email to me and it will go to Kwame. No. The transport layer is responsible for that. Just like how you are able to take your bus, your shuttle, from your hostel. Because you are the hostel, you are uniquely identified as a member of the hostel. And the moment you sit in the shuttle knows you are coming to campus. So there is no way the shuttle will not bring you to campus, but rather take you to Takrady or Accra. No. I believe you understand what I mean. Let me see if there is any question on the page. Yes, Logan says, why do we learn OSI? Learn ISO, that is the International Standard Organization, in the OSI model, when modern technology uses TCP IP, which is essentially ISO, but layers gets compacted into one layer. Yes, as you move along, you realize that these 7 layers have now been reduced to 3. Sometimes you will see it as 4. But this standard forms the basics for computer networks. In fact, the ones that you see as 3 or 4 usually have been compressed because of this. But because you are students, you need to see the reason why we have these 7 layers. And of course, the compressed one, if you go in there, you will see that each of these needs to be have been broken down and compacted in a way. So of course, you should know each one of them. Somebody is asking if an obsolete network card prevents you from connecting to a network. It is possible. It depends. If it's a wireless card and you have to probably update it and you don't update it, there is a likelihood you will not be able to, have full access to it. Of course, there are new technologies. So those wireless cards, it's not every wireless card that is able to connect to. It's not every wireless network card that is able to connect to a wireless access point or router. It depends on the technology that is being used by the wireless access points. That is what helps. Please do not throw sausage pizza away. Indeed, in Katia, yes, that is it. Have that in mind. Yes, so all right, so that's about the transport layer. Now let's talk about the session layer. Of course, as our gentleman said, we have a compressed version of it, but we want you to know the 7 layer. That is why we always talk about this. And of course, those that are into the computer people, that's good, and let's even delve into it. These are things that you should know. The OSI reference model, you can never miss it. You always have to have an idea what it is. All right, of course, we have new technologies and new things that come up, but they all take the basis from the OSI reference model. All right, so I believe Logan gets me now. All right, let's continue. All right, so yes, let's talk about the session layer. So what it does is it defines a means for coordinating communications between the sender and the recipient. So this layer usually establishes by managing and also terminating connection between applications. So sometimes you're on a network and something, maybe you are logged on to Facebook, and sometime when you leave it for a very long time. When you come back again, it says your session has timed out. Sometimes this is what really happens. So it defines the means for coordinating communication between the sender and the recipient to see if that's of course sometimes these sessions we could have it in 30 minutes. So if about 30 minutes of inactivity, you'll be signed out of maybe your browser or something. These are all possible. So the session layer is what it does is it establishes, manages, and terminates connections between applications. The next one is the presentation layer. What it does is it defines the way data is formatted, and also encoded before it is transmitted. And by encoding, we mean to say, sorry, the information that you send across board needs to be encrypted. By encoding, it needs to be encrypted to prevent people from eavesdropping and having access to it. So this layer usually provides independence from differences in data presentation by using encryption. And by so doing, it does some translation from the application to the network format and also vice versa. So the presentation layer usually defines the way data is formatted and encoded before it is transmitted. The application layer, defines the way applications such as email programs interact with the data transmission system. So usually all the application software that runs on an operating system that uses network. I'm coming again. Application software that runs on operating system that require computer network resides on the application layer. An example is your browser. It's an example of an application software that runs on the application layer. And this is because your browser has access to the internet. It's connected to a network. An example can also be Skype. Skype, for instance, is an application software that runs on an operating system. And the same application software has access to the internet too. So if you have an application software that has access to a network, that application software runs on the application layer. Excuse me. So the application layer defines the way applications such as email programs interacts with the data transmission system. And these application normally uses what we call specific ports. So Skype has a specific port that is able to communicate. excuse me, excuse me, just a minute. To communicate with the server. Yeah, Skype has a way of communicating to its remote server, which is the sender, and it uses a specialized protocol. So the application layer implements specific communication for each kind of program. So if you are using the browser, usually the browser you'll be running on HTTP or HTTPS protocol. If you are using a mail client like Tenderbird or Microsoft Outlook, you probably will be using a protocol of POP3 or IMAP. I'm sure some of you have seen IMAP on your phones. If you are using, you are communicating to a server using using the command prompts. Usually, you'll be by using a software like PuTTY or PuTTY, you'll be running through a protocol called SSH. Excuse me. Just a minute. Let me just pause for a second. Okay, sorry about that. Yes, so that is the application layer. So now when you have your computer and you are not connected to any network, you have to pass through these 7 layers before you can have access to the internet. You have to pass through the physical layer. Let me make sure you can hear me. Okay, I think you can hear me. You have to pass through the physical layer. You have to pass through the physical layer by having a network card, pass through the data link layer by connecting your network card to be able to connect to the network, or your wireless card to be able to connect to the network. You go through the network layer where IPs are given to your device. The moment you go through the network and you are uniquely identified on the network, that is when you are able to connect, have access to the network. You pass through the transport layer where the information that you might want to send would have to go through the right channel. The session layer where the communication, the coordination between the sender and the receiver is checked all the time to make sure the session is always active and valid. The presentation layer, where the data that you might be sending is encoded or is encrypted. And finally, the application layer. So when you connect your computer to the wireless network card, all these things go through quickly. It happens at the fastest speed. You go through all these 7 layers. So at the final layer, which is the application layer, that is where you launch your browser and you type google.com, you go there, or gmail.com, you go there, you send an email. The moment you send the email to maybe Amma also might have gone through all these and already connected to the internet on her computer. So she already has her browser also opened. So she's also able to see the email in her browser. She already has get herself connected, so she sees it in the browser, which is where the application layer exists. And if Amma is also sending you information, she also has to now start from the application layer, create an email, reply the email to you. The moment she does click on reply, it goes to the presentation layer, it goes to the session layer, it goes to the transport layer, it goes to the network layer, it goes to the data link layer, it goes to the physical layer. Then it's moved from her physical network card to the wireless network card. Then it goes online. So this process, before you start, you go this way, and the moment you are done and you are sending information, you have to pass through this way. So it's more like a cycle. Go this way and come this way. So that is how it works. So that is about the OSI model. Please, these have been, I would want you to go through this one as well. Make sure you understand it very well. It comes in the exams most of the time. Now, there are 5 main reasons for networking. If you recall, I said the reason for networking is to be able to share network resources. That is the whole thing. So everything that we talk about is sharing. All right, we have networking, computer networking, mainly because of sharing of network resources. So the first one is the sharing of technological resources. An example is a printer. It doesn't need to be a computer. The next one is the sharing of data such as text, picture, video, audio. So that is also an example of something that we share whenever we talk about computer network. Let me just add audio to this. All right. So audios and also videos. The next one is distributed data processing and client server systems. Now, when we talk about, as the name says, distributed data processing, so information processing that uses multiple computers at multiple sites that are tied together through a communication line. So distributed data processing, this is what happens. There are times, I think MTN and I think Vodafone have this, because we the computer science some years back, we went to their data center and we saw some of these things. And if you recall, when I talked about mainframe computers, I said you can have these resources, the CPU, the disk, and also the memory, packed in the way that they are virtualized. Once they are virtualized, you can have it in a way that one computer can be combined. You can have 20 computers combining all their resources together to form just one computer. So in a distributed data processing, you can have one computer here, because its computing power is not good enough or it's not strong enough. We can have a data sent to the computer here, another one sent to another computer, maybe in Takrady or whatever. So in actual fact, the computer is distributed, but they are connected together. So data that is sent to them is distributed sometimes evenly amongst these computers, and the processing is done. So that is how distributed data processing really works. So we have distributed data processing, which normally does data processing, and we also have the client server system too also happening. So a computer might not be able to perform a task by itself, but with the help of others, you'll be able to perform a task together. So that is how the distributed data processing works. Now, the client-server system, I told you about that. We have the server, we have the client. So, like the VLE serves as a server. There is a server, and you are using your client, which could be your phone browser, to connect to the server. So, a type of distributed system in which the processing power is distributed between central server and a number of client computers. So the server, the VLE is a server that is located at the ICT unit, but because you want to have access to the VLE, you connect through the browser, which is the client software. We can have so many client software or computers connecting to the VLE at the same time. So that is how the client server architecture or system look like. So the server is situated somewhere. We have a client which normally we use our phones and stuff to be having access to the VLE, to the server. So that's how the client server architecture works. So another reason for networking is enhanced communication. Of course, telecommunication networks provide the ability to communicate through email, bulletin board, blogs, instant messaging, wiki, video conferencing, like what is being happening now. So the provided links between the organization can lead to a strategic advantage in terms of business transaction. So because of networking, we have enhanced communication. Some time back, we're using Telegram to send information to people. And that could take days or months before a message that was sent is received by the right recipient. But because of computer networking, we are able to have an enhanced telecommunication. You are in Ghana, you are able to call somebody in US. You are in Ghana, you're able to WhatsApp somebody in US. You are in Ghana, you're able to take an online exam, which is probably in US. You are in Ghana, you are probably you are working remotely in a company somewhere in US. So all these are possible because of enhanced communication and because of networking, computer networking. Market outreach. So marketing outreach. So we have businesses that try to share their data with customers to advertise or sell their product through a corporate web presence. So that's like how Facebook is able to put up adverts and so on and so forth. All these are possible because of computer networks. Now, networking and communication application, we have the wireless phones. So these are examples of communication applications. The wireless phones, usually the ones that we have been using is the cellular phones. We normally call it as cell phones. So that is cellular phones. We have satellite phones too as well. Those that have watched, movies, especially the military war movies and stuff. You will see a military man somewhere in Afghanistan or somewhere in wherever, holding some phone, looking more like a walkie-talkie. And that phone is able to call anybody on the planet. So those are satellite phones. They are very robust. They can last for a long time before possibly their battery even die. So paging and messaging. Those of you who have watched Grey's Anatomy before, if you don't know what a pager is, let me see if I can show you an example in the browser. Let's see if we can get an example of a pager. All right, so those that have watched Grey's Anatomy is a movie. It's more of a medical medicine movie. Sometimes you see maybe a doctor, in a ward or something, and all of a sudden he hears peeping. So he picks this device from his maybe belt or in his pockets and reads what is there. So that is how the pager looks like. This is an example of a pager. And usually it's more like a text message. So he reads the information that is being written on there. So these are examples of pager. You see how small it is. So this is an example of a pager. I think now people don't really use pagers because of cell phones and the rest. Yeah. And it's all because of computer network. GPS, Global Positioning System. So you're able to know the location of people. We have the trackers because some people are able to put these trackers in their vehicle. So wherever you are, their car is, they're able to see. This is how some of the trackers looks like. And these are all possible because of networking, computer networking. So some of the trackers look like this, so small. And usually, sometimes you do put a chip inside. Yeah. All right. So these are all examples of GPS and the rest. Online conferencing, online meeting, video conferencing, web conferencing, collaborative computing. But video conferencing, web conferencing, like what is happening here and sometimes also on Zoom. Collaborative computing, being able to collaborate with other people. Sometimes you have a document. Whilst you are editing a document real time online, another person is also able to edit the same document real time online. And this is a way of collaborating. It's a collaborative computing. We are able to do things at a faster rate. Telecommuting. So, telecommuting. We have telemedicine too, also tele stuff. So telecommuting, I think there's examples. This picture says it all. So we have people being able to talk irrespective remotely. This person can be somewhere, this person can also be at different places. They don't need to be in an enclosed area to have a meeting. You can have a commuting or communication happening in there. Telemedicine also has to do with being able to render services like medical services, render medical services via online. So that is telemedicine. So let's see if we can get a picture like that. So telemedicine, yeah. So there are times, so for instance, you can have maybe there is a renowned specialist or surgeon who is in maybe in US, and there is an emergency somewhere in, let's say, Ghana. We also have a specialist, maybe a surgeon here in Ghana who is doing an operation. And this emergency is very critical. And unfortunately, he might need the help of the renowned surgeon in US. The Ghanaian surgeon might probably need the help of the renowned surgeon in US. So what he can do is by telemedicine, the renowned surgeon in US can assist the surgeon in Ghana to perform the operation or surgery by telemedicine. Just a way of, just like teleconferencing or commuting, but the main purpose is medicine. Having to, so he's able to see and guide maybe the Ghanaian surgeon what to do at any point in time. And that is an example of how telemedicine also works. If you want more information, you can read about it. I think it's getting to 9. It's getting to 10. You have a class at 10. So let's use the next 15 minutes to get yourself prepared for your next lecture. So I'm going to end here, and we will not have, because we've not been able to complete this lecture, we will not have our quiz, God willing, next week. So God willing, next week we will not hold a lecture. We will not have a class. Sorry. Let me come again. God willing, next week we will not have our quiz, but the lecture will come up. We will have our lecture, but not the quiz. So no quiz next week, but our lecture continues next week, 8 o'clock. So please come around and let's finish the lecture. And those of you who have not been coming to class, please try to come. I keep track of certain things that you have no idea of. Those that know others have not been coming, please entreat them to come to class. All right, so Moses, you can ask this question the next time we meet again. So let's call it a morning. Get yourself ready for the next class. Thank you very much.